Algebra 1 EOC Star Review, Category 1, on page 5, we're looking at exponents. So first note, on your star formula chart, you will be given the laws of exponents, the multiplication law, division law, power law, rational exponent, and negative law. One law that you do not see that we have talked about, that we know any base raised to the 0 power e is 1. So you might want to jot that down on your formula chart somewhere. That's a good reminder. The first problem we're given is two monomials being multiplied. So right away we can identify that as our green or multiplication law, in which we're going to regroup, write our coefficients, 4 times 7, put our x's, our bases of x's together, our bases y together, and our bases z. The multiplication law tells us, well, 4 times 7, we'll go ahead and multiply our coefficients as normal. Multiplication law tells us that we can add exponents. So x to the first times x to the second is x to the third. We would get y to the 21st here, and then negative 3 plus 3 is 0. So now that our numerator is simplified, we would then go ahead and bring down our denominator, which now we are going to be applying the division law, our blue law. It tells us when we are dividing like bases, exponentials, we are able to subtract exponents. Once again, if we group these together, we would divide our coefficients, 28 divided by 12, as normally, like you normally divide. 12 does not divide into 28 evenly, so you have to find your greatest common factor. And it looks to me like that would be 4. So 4 divides into 28 7 times, and 4 actually goes into 12 3 times. So believe that's a typo. If you would fix that, it should be 7 over 3. X raised to the negative 3, we subtract exponents. Y to the 17th. And the last one, 0 minus negative 2. A little tricky here, but 0 minus negative 2 we know would give us a positive 2. Not quite simplified here. If we look at our negative law, we see we have an unhappy cow, x to the negative third. So remember, we want to rope that unhappy cow and move it to the other side of the fence to greener pastures where now the cow becomes happy. So it would be 7 y to the 17th z squared all over 3 x to the third. Here we have a base raised to a fraction exponent. So that's 1 over 3, or that's why we use the rational exponent. It's a ratio, 1 to 3. So we do caret top raised to, and we will divide. So we've also talked about where you could distribute the 1/3 and multiply by 1/3, but multiplying by 1/3 is the same as dividing by 3. So we would have 64 raised to the 1 divided by 3, which gives us 4 if you type that into your calculator. Base A, raised to the 6 divided by 3. And then base B, raised to the 3 divided by 3, which would give us b to the first. Now remember, it is not necessary to write an exponent of 1. It's already understood, so we do not have to write that exponent of 1. So your final simplified expression here would be 4a squared b. Here's a application type problem. The area of a square is 49x to the 6th y to the 10th. What is the length of each side of the square? So underlying some key information, we're given the area of the square. We want to find the side length. What is the side length of the square? So we can simply do this by taking the square root of our a value. So this again is our rational exponent law that tells us to take the base. So our first base is 49, and we're going to raise it to the exponent of 1 divided by our index, which is 2. So it's going to be 49 raised to the 1/2. Then x raised to its power divided by the index, which would, so 6 divided by 2. First off, we do 49 caret top, 1/2, we get 7. Then we go x raised to the 6 divided by 2. And then our last base is y, and it's also being raised to 10 divided by 2. So its power divided by the index would give us y to the 5th. So our simplified expression is 7x to the 3rd, y to the 5th.